funky fresh coders, it's Prof. G, and in this lesson you'll break out the electric bass, cue up the horns, and crack those code knuckles for some big learning, because we're about to bring on to Func by learning functions in CircuitPython. We'll cover functions with no arguments, functions with multiple arguments. We'll learn why correctly using functions is a better and more efficient way to code. We'll have a brief challenge, and this will set us up for Bring to Func 2, our next lesson, where we'll cover more funky concepts, the key issue of variable scope, and at the end of that lesson we'll have a big challenge that spans several lessons of learning. Let's get funky with CircuitPython functions. So Codemeisters, plug in that Circuit Playground and spark up the PyCharm, and if you're new to the playlist, here's where you can find all the goodness that brought us to this point. So I'm going to assume everybody here has the wave button code up. In the prior lesson, Bring On to Noise, we wrote this code that played sound, but we noticed that some of the code was identical in two spots. We're going to correct this by creating a function, then we'll expand this function in various ways to learn more about functions in Python and how variables behave when interacting with functions. Before we make any changes, let's change the comment up top to read function.py. Now we can see here that we have repeated code that's nearly identical in two spots, but there's a principle in programming known as dry. Don't repeat yourself. Repeating in programming is bad. Repeated code is more difficult to maintain. The more places you need to make updates means the greater chance of errors. You could make a change in one place and not another when you mean to make it in both. And if you need to use this chunk of code again, say you need to write additional buttons or play different sounds, you'd be writing more code instead of just calling a reusable chunk of code. So let's write a function. A function is a reusable chunk of code that we can call anywhere whenever it's needed, and this will let us stop repeating ourselves. Creating a function is referred to as defining a function. So we're going to start by using the def keyword. This says we're defining a function. Then we give the function a name. We usually use lowercase snake case for function names in Python. We follow this with parentheses, enclosing any arguments in parentheses, and add a colon after the parentheses. And the code indented below the function definition line will be part of the function that's executed when it's called. To call a function in your code, just give the function name followed by parens and any parameters, and it will immediately jump to the function and execute all of the code in the function body. Now in Python, functions need to be created before they're called. We're going to define it above our while true loop, but outdented even with the while true loop. We'll start with the keyword def space. Then we'll call this play_sound. We'll add parentheses, initially passing nothing between the parentheses arguments. Sometimes those arguments are called parameters. We'll end this with a colon. Function defined. And notice when we press return, we have lines indented. So just like our while statement and our if statement, the items indented below the func are part of that related block of code. And when called, this function is going to stop running at the first line of code that's outdented at a level even with our function definition line. So now let's highlight this repeated block of code down here. That should be from the with statement through the pass statement. I'll highlight it in this one area and cut it out, and then I'll highlight it in the second area and I'll delete it. Then I'll paste it below the function definition. Make sure your indentation is right. Remember, Python is very fussy about indentation. Get it wrong and your code won't run. But I'm going to make the change in here where I change the literal, the string that's passed in where the file name was, and I'm instead going to use a variable, file name. Now the way we call the function in our code is we just refer to the function name passing in any arguments. If there are no arguments, you still need to have those parentheses. So let's call it below the code that recognizes each button press. Play sound open close paren here, play sound open close paren here. But to make sure we set the correct sound, let's make sure we change the file name variable just before we call play sound. So for button A, we'll say file name equals the string drum underscore cowbell.wave. For button B, we'll say file name equals scratch.wave. Now let's open the terminal, make sure you're in TO, save, and we'll try this out. And it works the same way, just a lot less code. Now you might look at our code and think, hey, we still got some areas of improvement. We set the file name before calling the function. We do that after checking button value A and button value B. It'd be great if we could just pass the file name in as an input to the function. And you might have guessed it, we can. This is how you do it. We'll just enter an argument, again, sometimes called a parameter. So we'll do that up here in the function definition line, and we'll call this one file name. Now notice we were already referring to file name, but that was this external variable up here. Now we're passing it in, so we don't need to make any changes to the with open line here. We're still using file name, but this time we're getting it from the argument. Then we call the function by passing in the file name. So here when button A is pressed, I'm going to backspace over play sound and watch what happens when I retype it. Code completion knows that play sound now has an argument. It shows file name in here, so we'll just enter the string drum_cowbell.wave. Then down here in button B, we'll do the same thing, calling play sound, but passing in scratch.wave. Now we can delete both of these lines where we set our file name just before making the function call. And this also means we can get rid of this line file name equals drumcowbell.wave. We don't need that anymore. So look at what we did. We added a parameter to our function, and we got rid of 3 lines of code. Cool. So let's save and check this out. And it works the same way with less code. By the way, what we're doing here, by changing our code to make it more efficient without altering the underlying results, is called refactoring, and you'll hear that term a lot in programming. And this is a nice standard play sound function. So why don't we change the comment at the top to say play_sound, and we'll save this as play_sound to our CircuitPython school folder. So now you've got this handy in your folder if you ever need to grab some code to play sound. And then we'll close the extra window so we're back at code.py. And now we're ready for a challenge. So you can see in our code, we have 2 print statements, A pressed and B pressed. Modify the play sound function to accept a second parameter, the name of the button, and call it button_name. In the play sound function, print the button_name so that the code still prints A pressed or B pressed each time the button is pressed. Call a function passing in the 2 parameters, the button name and the file name, and delete those 2 extra print statements. Save as 2-param-function.py. Pause. Give this a shot. I know you can do it. And when you're ready, resume, and we'll compare answers. So hopefully you got this. Just add a parameter button_name in between parens in our play_sound function definition. You can add it either before or after the existing file name parameter. I'll add it before. You do need a comma separating the argument labels. Now let's add a print statement as the first line in our function. Print, and in parens, let's make this an F string with F double quotes, curly braces inside the quotes, then after the curlies, space pressed, and between the curlies, we'll add the variable button_name. Then where our play sound function is called, in this first function call, I'm going to pass in the string A as my button name, comma, then the name of the file, drumcowbell.wave, and it seems that if you enter literal values like we've done here with these 2 strings, PyCharm adds argument labels out front automatically, and in the second call, we'll pass in the string B, and comma, scratch.wave, and we can delete the 2 extra print statements. We don't need those anymore. Then open the terminal and TO and head up top and save. And try it out. And it works great. No change. We see things are printing out fine, whether it's A or whether it's B. So we'll close the terminal. We'll change the comment up top to 2-param-function.py. And I'll save this to the CircuitPython school folder. And close the extra window, and we'll cover more about functions in the next lesson, but let's recap the big learning. We learned about dry, don't repeat yourself, and why functions are better than repeated code. We coded a function with no parameters, but also functions with 1 or more parameters, and we learned the term refactoring. So Functacular function phenoms, buckle up for some more big learning, because there are more key funky concepts in the next lesson, where we'll tackle variable scope and functions with return values. Plus, we'll have a big challenge at the end of the next lesson that tests your knowledge of concepts over the last few lessons. Until then, continue to make something awesome.